This is the second video in the series on how to do Lewis structures of covalent compounds. In this video, I'm going to show you how to draw a Lewis structure using an easy example. These are the directions that are on the piece of paper that I gave you. And for this one, the formula we're going to do is CHCl3. You need the chemical formula for the compound that you're going to draw. The first step is that we would add up all of the valence electrons for the atoms in the formula. We don't need to worry about the next line. I'll do that in another example. So carbon has 4 valence electrons. Hydrogen has 1 valence electron. There are 3 chlorines in this formula, and each chlorine has 7 valence electrons. So if I add that up, that's 21, 22 plus 4, that's 26. So that's my step 1, 26 electrons. Step 2, I'm going to divide the number of valence electrons from step 1 by 2 to get the number of pairs of electrons. So I'll just divide this by 2 and I get 13 pairs. That's step 2. So step 3, we're going to look at the elements that we have in our formula, and we're going to place the symbol for the least electronegative element in the center. We're going to surround it with the symbols for the other elements. Except hydrogen, it doesn't matter what its electronegativity is, it can never go in the center because it's only ever going to make one bond. So then if I compare carbon and chlorine, chlorine is closest to fluorine, meaning it's more electronegative. I'm going to put my carbon in the middle. Let's stick the hydrogen up here, and then I've got 3 chlorines that I'm just going to surround my central atom. Step 3, done. Now I'm going to use 1 pair each to connect the non-central atoms, these surrounding ones, to the central atom, and then once I've done that, I'm going to subtract those from the total that I got right here in step 2. So here's 1, 2, 3, 4 pairs that I've drawn as single bonds, so subtract out 4, and that leaves me with 9 pairs left. So that's step 4. Step 5, we would put pairs of electron dots on the non-central atoms to fill up their octets. Except for hydrogen, it gets no pairs of dots. So I'm going to start with this chlorine, and I'm going to give it a pair of dots. That's 1. Here's 2. That's 3 pairs that I've used, so subtract that out, and I'm going to have 6 left. And then if I look, this one now has an octet. There's 1, 2, 3, 4, 5, 6, and this bond is 2 more electrons, so there's 7 and 8. This chlorine has an octet. So I've got 6 pairs left. Let's do 1, 2, 3. That takes 3 out, leaves me with 3 left. So 1, 2, 3. And now I'm out of pairs to give. That's step 5. I don't have extra pairs, so I don't have to do step 6. I did run out of pairs, so I have to check each atom for an octet, and then I can move electrons if I need to. So hydrogen doesn't have an octet, right? It's one of the exceptions, 1 line, and it's done. So that one's fine. The chlorines, I checked all of those, so the only thing we need to have checked now is our carbon. Each line is 2 electrons a pair, so it's got 1, 2, 3, 4 lines. That's 8 electrons. So everything in our picture has an octet or the amount that it wants to have. So step 8 is that we're going to check it to make sure it's right by calculating the formal charge, and you'll usually see that abbreviated FC. And we calculate that for each atom. The way you calculate formal charge is you take the number of valence electrons on that atom, subtract out the total of the non-bonded electrons plus the number of bonds. So I'll show you how that works. Hydrogen has 1 valence electron. It doesn't have any non-bonded electrons, and it had 1 bond. So that sum came up to 1. 1 minus 1 equals 0. If the formal charge is 0, that's great. Let's check the others. These 3 chlorines are all identical. They all had 7 valence electrons, and then they have 1, 2, 3, 4, 5, 6 non-bonding electrons and 1 bond. So 6 plus 1 is 7, 7 minus 7 equals 0. So the formal charge on this chlorine and this chlorine and this chlorine is 0. The last thing we have to check is our central atom. Carbons have 4 valence electrons. It has no non-bonding electrons, and it has 1, 2, 3, 4 bonds. So 4 minus 4 equals 0. Awesome. That's great. We don't have to do anything else because the formal charge on everything is 0. The last thing we're going to do is to get ready for our next step, The next step is to learn about the shape of molecules, and the shape is determined by the number of electron domains on our central atom. An electron domain can be one of two things. It can either be a non-bonding pair of electrons, or it can be a bonding domain. A single bond, a double bond, and a triple bond each would be considered one domain. So even though a triple bond looks like 3 bonds, it's still one electron domain. So our central atom here has a single bond, a single bond, a single bond, and a single bond. So we would say that this molecule has 4 electron domains. And you're finished with this example.